All right, today we're going to work through the review, which I have, and I've put a copy there on Canvas for you. If you haven't printed that off and tried it, you need to do so before just watching this video. Okay, so let me get my document camera up and we'll be going through it. Now, mine may look just a little bit different than yours, but all the problems are the same. Okay, so question one says find the value of x in each of the figures. Okay, so here we have a polygon and we're looking at exterior angles here. So no matter how many exterior angles you have in a polygon, it will always equal 360 degrees. So we'll set that equal to 360. Okay, and let's just count the number of x's. I have 5, 6, 7, 8, 9, 10, 11, 12. So I'd add all of that up. In fact, that's 12x. And that will equal 36. Sometimes you may have, expressions like this over here that you have to add in that. So just make sure you're adding all that up. Here I'm going to divide by 12. And x equals 30. Okay. Over here is a bit different because I have the interior angles. Okay, so I am going to add up all the interior angles. So here I have 90 plus 2x minus 5 plus 72 plus x plus 8x plus 3x plus 13. I kind of ran out of room there. And I have to figure out, what do I set that equal to? Okay, here I have 1, 2, 3, 4, 5, 6 sides. And if you remember, we kind of did this a while ago. If I split this thing into triangles, okay, I have 4 triangles there, and each triangle will be 180 degrees. So in this case, I'm going to take 4 times 180, and I get 720. So whatever this is, it must equal 720. There was also a formula that we had for that, which was 180 n minus 2. Okay, that would give you all the sum of all the angles. So I'm going to set it equal to 720. Okay, so 720 equals, if we go over here, add the x's. So I'm just going to combine like terms. So I have 2, 3, 6, and 8. So 6 plus 8 is 14. So I have 14x. And then I have 90 minus 5 plus 72 plus 13. Okay, and that is a positive 170. It's okay to use a calculator. I'm sitting here using one. Those are quite big numbers. I want to make sure that you get it right. Okay, so here I'm going to subtract 170. So 720 minus 170 is 550 equals 14x. And we're going to divide by 14. And we got x equals 39.29. Let me just double check all this over here. Make sure I wrote it down. So that's 90, 2x minus 5. I don't think it was a plus. 2x minus 5. 72, an x, 8x, 3x. Oh, that was plus 3, not 13. That's my fault. Okay, so 90 minus 5 plus 72 plus 3. So this would be a 60. So this is 60. So I should have taken 720 minus 160. It'd be 560 divided by 14, which is 40. Okay, my bad. I wrote that down over there wrong. Okay, so in this case, X got you 40. What polygon is described / created? Okay, so we've got some vertices here. So let me grab some graph paper here and I'll kind of go on this page and graph this out. Okay. So there's our graph. We have a point at -1, -1. We have a point at 0, 0, 3. We have a point at 3, 3, and a point at 4, -1. Okay. Now we did graph this, so we can kind of see what's going on here. So these two are parallel. They have a slope of 0. They're straight horizontal lines. And if I look at the slope of these, it's rise over run. So 1, 2, 3, 4 over 1. So that is 4 over 1. And this one, rise, is 1, 2, 3, 4 down. So that would be a -4. And I went right 1 over 1. So these two have different slopes, so they're not parallel. Okay. And if we look, these have a slope of 0 and 0. None of them have negative reciprocal slopes. So there's no 90 degrees. And in this shape, there's only one set of parallel lines. And when you have only one set of parallel lines, you have a trapezoid. Okay. But let's look to see if it's an isosceles trapezoid. If it's an isosceles trapezoid, these sides will be the same length. Well, I don't have to do a ton of math to know that they do have the same length. If I create a triangle right here, a right triangle, where this is the hypotenuse, this side is 1 and this side is 4. Over here, if I do the same thing, this side is 1, this side is 4. Even though they have different slopes, this side will be the same because the legs of your right triangle are also the same. So this is actually an isosceles trapezoid. And your work would maybe C graph. Okay, because we graph that one out. So if you need graph paper, just let me know and I can get you some. Okay, here we have 4 congruent sides and 4 congruent angles. Okay, so if I have a shape with 4 congruent sides, I don't know what they are, and 4 congruent angles. Well, the angles have to add up to 360. Okay, and if all of them are the same, I'll just take 360 divided by 4 and I get 90. So all my angles have to be 90. So if you have a shape where all the sides and all the angles are the same, this is what it would look like. And this is a picture of a square. Okay. Here, this is a little bit different. I only know that the sides are the same. Okay, I don't know anything about the angles. So if the sides are just the same, it's a rhombus. Okay. Remember, a square is both a rhombus and a rectangle. The angles are the rectangle part. So this is just a rhombus. Okay, here on D, we have another graph. So we'll go back over here and graph this thing out on a new graph. Okay, -3, 0, 0, -1. So we'll connect those two. 2, 5, and -7. So 3, 4, 5, 6, 7, 8. 1. So we've got this pretty crazy shape here. Like so. Okay. Now, hopefully you'll be able to tell right off the bat, since we graphed it, that this is not a parallelogram. Okay, this side is not at all parallel to this side. So if we can determine it's not a parallelogram, that gets rid of square, rhombus, and rectangle. So now we're looking at kite or trapezoid or isosceles trapezoid. So let's just go ahead and find the slope of each. Okay, so starting here, we have rise over run. So 1, 2, 3, 4, 5, 6, and right 2. So this slope is 3 over 1. It's a positive slope. This slope is up 1, 2, 3, 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9, and it's negative because it's falling. So 3 over 9 reduces to -1/3. Okay, now if we notice here, these are negative reciprocals. So I have a right angle right here in those negative reciprocals. Okay, this one's also falling. So its rise is 1, 2, 3, 4, 5, 6, 7, 8. So you have 8 over and it's negative. And we went 1, 2, 3, 4. That reduces to negative, divide both by 4, 2 over 1. Okay, which we can see those are not the same, so they're not parallel. And this one is a negative because it's falling. So it is rise is 1, and it went over 1, 2, 3, so 1/3. Here we can notice that this and this are the same. So these are parallel to each other. Okay, and so I only have one set of parallel sides. So this is a trapezoid. And here, again, like before, we can find the length of this. If I make this triangle here, this right triangle, this side is 4 and this side is 8. Then if I make this triangle over here with this side is 2 and this side is 6. Okay, now let's look. These are different. Okay, and just because they are different doesn't necessarily mean well, it means that these sides will not be the same. Okay, they might be similar, but remember, to be an isosceles triangle, they have to be the same. And if you want to go through this and do the Pythagorean theorem, 2 squared plus 6 squared equals x squared for this one, and 4 squared plus 8 squared equals x squared for this one. Okay, so you have 4 squared is 16, 8 squared is 64, 2 squared is 4, 6 squared is 36. So this is 40. And you take the square root of that. So this length is a square root of 40. We don't need to reduce that anymore. Okay, and then this one, that would be 80. And then we'd take the square root of that. And this is a square root of 80. Okay, the square root of 80 does not equal the square root of 40. So these are not the same. So in this case, on this one, we just have a trapezoid. Okay, and again, see graph. Okay, we had a lot of work on the graph on that one. Okay, let's look at number 3 here. Number 3, they say find x, y, and the measure of angle M. So here's the measure of angle M here. Okay, and it looks like here's some parallel lines, here's some parallel lines. So I have a parallelogram, and so we need all the properties of parallelograms. So here I can see they give me some sides. Okay, opposite sides in a parallelogram are congruent. They equal each other. So you have 18 equals 3y plus 3. We're going to subtract 3 there. So 18 minus 3 is 15 equals 3y. Divide by 3 and you get y equals 5. So you get a 5 there. Okay, x is an angle and this is an angle. Okay, now opposite angles in a parallelogram are the same. So this angle down here is 50, and this angle down here is 4x plus 10. Okay, now in a parallelogram, consecutive angles, no matter if I pick these two or these two, they will add up to 180. So we're going to take 4x plus 10 plus 50, and I will get 180. 180 degrees. Okay, so I've got subtract 10, subtract 50, subtract 10, subtract 50. So 4x equals 120, because that's 60. 6 or 8 minus 6 is 2, so you get 120. Divide by 4, and x equals 30. Oop, not 36, 30. So x here is 30. Now, I want to find the measure of angle M, so all I have to do is take that 30 and plug it back in. So the measure of angle M equals 4 times 30 plus 10. 4 times 30 is 120, plus 10 is 130. So the measure of angle M is 130 degrees. And we can see here, 50 plus 130 is 180. All right, here, it looks like they tell me all the sides are congruent. Okay, that tells me it's a rhombus. Okay, all the sides are the same. It's a rhombus, so which is also a parallelogram. So opposite angles are the same, and all the sides are the same, and it wants to find CD. Okay, so here I'm going to set these two sides equal to each other. 3y plus 19 equals 6y minus 2. So we'll subtract 3y. 19 equals 3y minus 2. Add 2. 19 plus 2 is 21 equals 3y. Divide everything by 3, you get y equals 7. Now that'll help me find CD here, because CD will be the same as any of these. Okay, so if I take it and plug it into 3y, I could have plugged it into this. It doesn't matter. So we're going to take 3 times 7 plus 19. 3 times 7 is 21, plus 19 would be 40. Again, you could plug it in over here. Okay, 6 times 7 is what here? 6 times 7 is 42, minus 2 is 40. So we got 40 again. With x here, opposite angles are the same. So you get 3x plus 6 equals 87. So those are equal. We'll subtract 6. 3x equals 81. Divide by 3. And x equals 27. So x here is 27. Okay, so just you need to know the properties of all these shapes that we went through. All right, find the area and perimeter of the shapes. Okay, let me zoom in here just on this one. Okay, here we have 1, 2, 3, 4, 5, 6, 7 sides. Okay, so to find the perimeter, looks like it's 35 feet right here. So to find the perimeter, we're going to take 7 times 35, because we just add up all the sides. And 7 times 35 is 245 feet. Okay. Now, for the area, remember we take and we split this thing up into a triangle. And in fact, I'm going to have 7 triangles. So we're going to take 7 times the area. Let's just focus on this triangle right here. To find the area of the triangle, that's 1/2 base. So how long is this, which is 35, times your height, which in this case, they give me the height or the apothem to be 36.4. Okay, and all I got to do is put all that into the calculator. So 7 times 1/2 times 35 times 36.4. And we get 4,459 feet squared. It's square because it's area. Okay, here they give me some vertices of a shape. So we'll come back to the graph here. And there's 3 points, so it looks like it's going to be a triangle. So I have -4, 2. So there's that one. 1, -1. There's that one. And 2, 2. Okay. So I have this shape. So I need to find the perimeter. So I add up all the sides. Now I don't have the length for every side. So this is 1, 2, 3, 4, 5, 6. This one's 6, but this one goes through the diagonal. So I don't have the area for that one. Or I don't have the length of that one. I also don't have the length for this one. So I need to make this triangle, this right triangle like we've done before. It's a 1 and a 3 to find the length. So I have 1 squared plus 3 squared equals x squared. I got to do the same thing over here. 1, 2, 3, 4, 5. This is 5 and 3. So 3 squared plus 5 squared equals x squared. So 3 squared is 9. 5 squared is 25. 25 plus 9 would be 34. So x is the square root of 34, and we're just going to leave it like that for now. This is 1 plus 9 equals x squared. That's 10 equals x squared. So x is the square root of 10, and we'll leave it like that. Okay, so for the perimeter, we're going to have 6 plus the square root of 34 plus the square root of 10. And we may get a decimal there. Okay, so 6 plus the square root of 10 plus the square root of 34, which is about 15 units. Okay, for that. Okay, so now we need to find the area. Okay, so the slope of this line, okay, the slope of this one is 0. Remember I need the base times the height, and the height has to be perpendicular to the base, okay, or 90 degrees. Well, this is a horizontal, so a vertical line must be the height, and it has to go to the top, okay? So the only place is right here, okay? A horizontal and a vertical line create a 90 degrees. And this length right here is 3, okay? I could have come and done this height of 3, or this height is all 3. So this triangle is 3 units tall. So to find this area, we're going to take 1/2 times the base, which will be 6, times the height, which is 3. Okay, so you have 6 times 3 is 18. Half of that is 9 units squared. Okay, so there's your area and perimeter. We'll go ahead and just mark it on here. We have 15 units and 9 units squared. See graph. Okay. So that was number 5B. All right, and our last page here, starting with 6, it says classify the shape using slope and distance. Okay, so we have some lines here to graph. Okay. So if we look at these lines, I'm just going to kind of graph them out, not on graph paper, but just kind of on a sheet of paper here. So the first line, so let's say this is my graph. The first line is y equals 4x plus 3. So let's say I'm here at plus 3. It has a slope of 4. So that means it's rising fairly steep. So I'm going to say let's just say that's this line right here. Okay, so y equals 4x plus 3. Looking through here, I have another line that is 4x minus 2. So let's say 4x minus 2 is down here. It has the same slope of 4. So this is y equals 4x minus 2. So those two are parallel to each other. And if we look at the other two, they also have the same slope as -1/4. So one is at 2, one might be like right here, so -1/4. And the other one might be down here, -1/4. So this is y equals -1/4 x plus 2, y equals -1/4 x minus 3. Okay. So I do have a parallelogram. So parallel, 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 parallel. Okay, I do have a parallelogram. And in fact, if we look at the slopes, this is 4, this is -1/4. Those are negative reciprocals. So I have 4 right angles. Okay. So I wanted you to see that on here, so we can see the parallel because if I actually graph this, it's a pretty small shape. But I am going to graph it now because we need to check to see if the sides are the same. Okay. And I can't really see that on this graph because I didn't actually plot points. So if I come over here, right here. Okay, if I graph the first one, which is 4x plus 3, so I go to plus 3 right here. And I go 4x, so that could be down 4, 1, 2, 3, 4, left 1. Okay, so I'm going to draw that line right here. You can see it's rising. Okay, the one that had the same slope was at -2. And you go up 4, 1, 2, 3, 4, right 1. And there's that line. Okay, so there's those two. Whoop, you can't even see that. There's those two. Okay, again, this wasn't drawn to scale, just checking the slopes. Okay, and then the other two were at +2, and it had a slope of -1, right 4. So there's that line. And -3 with the same slope. So that could be up 1, left 4. So it could be something like that. So here we can clearly see that these sides are not all the same. Okay, so in this case, it is just a rectangle. Okay, see graph. Whoop. Okay. All right, we've got some points here that we will actually graph. This is number 6, part B. Okay, I'm at -4, 0. I'm at 1, -1, -5, -5, and 0, -6. Okay. Just by looks, it's kind of looking like a square. But I can't go off of looks. Okay. The first thing I want to do is look at the slopes of everything. Okay, which is rise over run. So 1, 2, 3, 4, 5 over 1. Okay, let's look at this one. 1, 2, 3, 4, 5, right 1. Okay, so those are parallel. Here we've got 1, 2, 3, 4, 5, 1. Now I went left and up 1. So my rise is 1, my run is 5, and it's negative. If you notice, these two are negative reciprocals. They're flipped over. One's positive, one's negative. Same here. So here I have a 90-degree angle. And then this one here, I go up 1, and I go left 1, 2, 3, 4, 5. So I go left, it's falling, so that's negative. So these two are the same. So these are also parallel to each other. Okay, again, we have negative reciprocal slopes on both sides. Okay, so I got parallel, 4 right angles. It is a parallelogram, 4 right angles. We're looking at a rectangle right now. Okay, so let's check out the sides. And we know that opposite sides are equal. So I really just need to see if these two are equal. Well, if we make our right triangle like before, okay, let me choose a different color here. If I come down here, that's 1, and I go over here, that's 1 and 5. Then if I go over here from this point, I make my right triangle, that's 1, and that's 5. So no matter what, these hypotenuse will be the same length. So in this case, if I have 4 right angles and 4 sides that are congruent, we have a square. See graph. Now, what defines the following shape? So this is pretty important stuff here. Okay, this is straight from our notes and properties that we use through this whole review. So what defines a quadrilateral? 4 sides, okay, closed, and segmented. Remember, segmented just meant straight sides. Okay, what makes a parallelogram? Well, a parallelogram is a quadrilateral, so we'll say quadrilateral. And it has 2 pairs of parallel sides. Okay. And that's it. A rhombus, okay, what makes a rhombus? Well, a rhombus has to be a parallelogram, which also makes it a quadrilateral. So we'll say parallelogram. And all it has is 4 congruent sides. Okay, so a rhombus is a parallelogram with 4 congruent sides. Okay, let's skip kite and let's go down to rectangle. Okay, a rectangle is a parallelogram. Okay, and it has 4 right angles. Okay, and then next to that is a square. A square is a rhombus and rectangle. Or you could have said parallelogram with 4 congruent sides, 4 right angles. Okay, you could have said that. Okay, here I put these on the same one, but they're two different things. So a trapezoid, we'll just do trapezoid right here, is a quadrilateral and it has one pair of parallel sides. Now, an isosceles trapezoid is a trapezoid and it has non-parallel sides congruent. So your non-parallel sides are congruent. Now, the last one is a kite. We don't deal with kites a whole lot, but we have seen them. So a kite is a quadrilateral. It doesn't have any parallel sides, but what it does have are consecutive, 2 sets of consecutive congruent sides. Let me just look and make sure I define it the same way we took it in our notes here. Okay, yeah, 2 set of congruent adjacent sides is how I put it in the notes. So 2 sets of congruent adjacent sides. Okay, so no parallel sides in that kite, but the adjacent sides, you got 2 sets of those that are the same length. Okay, all right, that's gonna do it for the review on the polygon test. If you have questions, feel free to reach out and we can work through those. If not, I'll see you in the next unit and good luck on your test.